Welcome back to the OpenVINO channel. The applications we are building are highly connected to sensors to get new information, connected to the cloud, connected to other applications. And for this, we need an efficient way to transfer data or metadata in a fast and secure way. For an example, think about thousands of cameras across a smart city, connected in a hierarchy of compute nodes. So every 6, for example, cameras are connected to an intersection computer or node. And every few intersections are connected to a neighborhood node. And all the neighborhoods are connected to the city main cloud command center. If we look at one branch of the system, we can see the chain of communication. And there is much to communicate. For example, camera number 1 has detected a new face. The intersection computer will extract the features or the landmarks of this face and communicate it to the neighborhood computer. The neighborhood node will collect all the inputs from all the intersections and communicate it to the command center. The command center might communicate downstream that one of these faces is a match, and so on. What I would like to do is to build a pipeline using the DL Streamer and apply it in a container to all the cameras. And another DL Streamer pipeline in another container to all the intersections, and so on. And these workloads, these pipelines, should be able to communicate with each other. For this, we have 2 new commands, meta-convert and meta-publish. The DL Streamer is using a unified database that could be used by all the pipeline stages to exchange data. It's called GST buffer, and it holds the frame data and metadata. Just YouTube OpenVINO 66 to learn all about it. The first stage is to convert the data in the GST buffer. This could be done using the GVA meta convert command. The command has few options, but basically convert the metadata into a friendly, readable JSON format. GVA meta publish is your way to communicate the metadata to others. It can use MQTT or Kafka protocols for doing that. I will talk about MQTT, but you can read about the other protocol in the documentation using the QR code. MQTT is a lightweight network protocol to transport messages between devices. MQTT uses a broker, a piece of software that controls all the communication. Every client can publish a message to the broker. Every message belongs to a topic, and the broker knows to communicate the messages to every client who is subscribed to this topic. Let me show you how it works. I'll be running the meta publish sample of the DL Streamer. I'm first checking that I have no Docker container running, as the MQTT broker will run in a container. First stage is to install MQTT, or if you're using Kafka, install Kafka, and install Mosquito, which is a small free open source MQTT broker program. And now I'm building a new script that will run the broker. The broker in this demo is only listening and printing the messages, so we can call him listener. You can see here the Docker command, and the container will run only mosquito_sub, basically print the messages it got. And it will listen to all the messages for the topic DL Streamer. So the listener is running an MQTT broker using Mosquito, listening to the topic DL Streamer. I'm running the listener in this window, and it's running, waiting for messages to appear. Now, let's look at the meta publish script. Basically, it takes a video input, decode it, perform detection and classification, then converts the result to JSON format using GVA meta convert, and then publish the JSON file using the method we choose, here it's MQTT, with all kind of parameters that you can check for yourself. And it's going to a fake sync. You can check this file for more details. Let's run the script. Input is video 1. Use MQTT. This is the host address for MQTT, and the topic is DL Streamer. You can see that the top terminal is processing the video, and the results are being sent to the bottom terminal, the MQTT broker. The broker, or the listener in this case, is printing the detection results. If I stop the sending script, nothing is received at the broker. If I continue, it continues. Pretty cool. I hope you can use this important capability. It can allow you to build multiple workloads or pipeline and communicate between them. Now, building a system of thousands of cameras is simple. Subscribe to the channel to get more videos like this one. Thank you.